Hello, everyone. So to be more specific, to be a side effects boss in front-end development. But before we go to the concurrency, asynchronously, and other fancy words in front-end development, let's do a little introduction of myself, for example. So my name is Katarzyna Jastrzębska. I'm a front-end developer for over 6 years now, and all this time focused around front-end development only. So I'm happily not touched back-end development at all. What's next? So I went through various frameworks during my work. It was Backbone, it was Ember, it was Polymer, and of course React, which is actually one of the topic of my presentation, which is Redux Saga. Can you raise hands? How many of you actually know what is Redux Saga? Okay, so we have like a 1/3 of our public, so it's not bad. But before we go to Redux Saga, let's start with React, because I chose React to show you how to work with Redux Saga, because React is awesome, as we know. Do you know React? Can you get raised? Sure, you know React. This is like a no-brainer. So React is awesome because of 3 things. One of them is components. So we just build huge application based on really small parts, which is really awesome because you can just simply build one component and use it everywhere when you want. One other thing, which is also awesome, is a virtual DOM, and probably you heard it already on this conference, maybe yesterday or even today. What is the virtual DOM? So I would just simply say that it's how React works under the hood. So it creates its own DOM, and just based on that, we are really fast by default React application. Another thing with React is how React manages state. Of course, we have many implementation of state management. One of it is Flux, and furthermore Redux. But even how components communicate one with each other is pretty cool and break free, because there is not as many possibility to, for example, break the communication through the component between components, because we have just passing our props from parent to children, right? And then if children somehow want to change, want to mutate our state, it has to pass the event to the top, to the parent. So it's pretty cool because, of course, we can add to our React, for example, immutable data, which is more cool than the mutable, but not every time, not in every application. It's not like we have to use them. What's next? React loves Redux, for sure, because Redux is like a ready-to-use full tool to build really huge applications with a really nice performance and state management, state of the application, caching application using local storage, or even keep the application data with a really cool domain separation, using reducers, because when you use one reducer, it's usually for splitting the data into domains. Okay, so why Redux is awesome? As I said, domain separation, which is really cool because we have one reducer which handles only part of the state, which is, for example, user, or I don't know, nodes, because I will, of course, I've created to do for you. As always, and the data flow, how it's handled, how the data flow works in Redux. Are you familiar with how it works? So actually, it was not a good sign for me, because I'm obligated to tell you now how it works. So we have action creators and action types, and every reducer is prepared to listen to given action types and react on them. It's more, it can be some kind of observable pattern, but well, it's more than that. And every action, when it goes through the Redux dispatcher, it's passed to the reducers, and if one reducer with domain, for example, user gets the type of action, for example, login, it reacts to the given action and manipulate the state. And then the state is passed to components with props. And of course, immutability. What is immutability? Immutability, oh, it's a hard word for me to pronounce, sorry for that. So what it is, we deal with a lot of mutable data in JavaScript in general. Mutable, which means that every time we just change something in our variable, it gets new data and forgets about the old one, right? So this is what it goes with mutable. When it comes to immutability, which is pretty functional thing in general, it can be implemented with immutability.js library and used by Redux, and then all this Redux state, so our data is immutable, which means that we can actually travel in time. So go like into the future or back. So it's pretty cool, right? Okay, so what can be possible problems? Probably, I love IT crowd, that's by the way. So what can be possible problems when we have so cool stack? So we have React with components, we have Redux with state management. What can go wrong? So, well, asynchronously, right? It's pretty common problem, because we have to handle a lot of communication between our front-end application and back-end and API, of course. Sometimes we even want to delay something to show users some kind of action. I don't know if you heard about the Facebook strategy for that. They sometimes just show you the loader to show you that some data was loading, even if it was so fast that the loader should like disappear after 1 millisecond. So they sometimes just show you the loader to show user indicate some kind of loading. So we have some delay just to make user sure that he is connected to internet. Okay, so problems with asynchronously and concurrency, of course, the fancy words, I have to use them a lot, are you familiar with the callback hell? Are you? So callback hell, this is like, this is a huge problem for JavaScript developer. Every time on recruitation process, you will be asked for that. What is callback hell? How can we deal with it? So this is some kind of approach to actually do some asynchronous coding. And what it looks like every time you just have another callback, which use another callback, and then we have just a really huge chain of callbacks, and you can easily get lost in it. So JavaScript came to us with a really nice solution for that, which is promises, right? But when you use promises, you actually have a pretty similar a look of code, right? Because you have then, and then, and then, and it can just take forever to work for promises. Of course, promises itself can do a lot more, because it can catch an error, handle somehow an error, and of course, break the chain. You have all the cool features like all or erase the promises, but can you actually cancel the promise? Nope, nope, you cannot. So this is a problem. This is a huge problem for JavaScript developers and async development. So as I said, but another problem is also, this is connected to reducers and Redux in general. So communication between reducers. Of course, as I said, we're splitting our data into domains, which should be separated and should never communicate, right? But this is like a theory. Usually, sometimes we just have to communicate to reducers. For example, if we log in our user, we want to show some data for him. And usually, reducer for user is separated from some data like notes or books or something from another reducer. So how do we communicate them? Okay, we can do it with our container, like a component with logic. We can just throw another action. We can do promise with login our user and then get data. But what could happen if we login our user and then we have to, for example, get more data, or even, I don't know, implement 3 promises, one after each other. We have callback hell as well, maybe based on promises, but this is it. So actually another problem with React, with Redux, is missing one layer of abstraction. Layer where we can take control and actually manipulate our concurrency. How? Because now, when we just use React with Redux, we usually say to our Redux state from the component, do something, do another something. But it's really separated into many, many components. So the logic is just split into a lot of many parts of code, which can be really chaotic to manipulate it. So the solution, Redux Saga, and what it is actually, Redux Saga is a pretty cool way of manipulate an async operation based on, oh, okay, sorry for that, but I would like to go for what's under the hood. So this is like so this is a library around generators. Generators are JavaScript functions which can be paused and resumed anytime we just use the next method in our generator object. What it means for us, it means that we can easily keep the state of our generator working somewhere in the background, but the working in the background means that it's not really working. It's just waiting for another next method for the generator object. So we have our generators. We have promises, which works now with generators. So no more callback hell, no more one promise calling another promise. This is more just doing one promise. If it succeeds, then just go with another promise, because it's still asynchronous, but written in a really cool way. And of course, how we implement our Redux Saga into Redux is just by simply using middleware. And we can use Saga middleware with many other middlewares, so this is really simple to implement, actually. But more about generators. So our generators are, as you can see, I don't have this fancy light thing to show you, but how you can see, it's just a function which every time when it's just used, it just gets, goes through the method. When it goes to the symbol yield, it stops, pause the state of the generator, and then return the value, which is after yield, and waits for another next. So this is about generators, which are a powerful tool. Now, in the next couple of months, or even it's now happening, the generators will be generators with promises will be used in async and await. Are you maybe heard? Did you heard about async and await? So this is pretty cool feature of our new JavaScript generation. So you can pause and resume. You have this is a huge advantage of generators used asynchronously, because we have the asynchronous work done, but still syntax is pretty simple, right? We have just method and another just a few lines of code, and every time yield is actually passed, it stops. And what's more, we can combine generators one with each other, which means that we can avoid building huge functions, huge methods which do a lot of logic, and just split them to avoid the dry anti-pattern, right? Which is don't repeat yourself, never. Okay, so what about the Redux Saga pros? So we have power of promises, which is huge because it's actually the real asynchronous operation. Communication through Redux actions, because our sagas are connected to middleware, which means that every action dispatched is listened by Saga, and Saga can react. Logic in one place. So believe me or not, but this is a huge advantage of Redux Saga, because in the Saga's files we have whole logic of our application, like the most important logic, because we still keep the communication through components, passing the props, of course selecting our data from Redux, from our reducers, but the logic of asynchronous operation are in Sagas. Delaying operations, and delaying operations means no more set interval in components, of course. The delaying is done by promise, so it's a huge advantage. What's more, we can actually do a queue of async actions, so we can get all of our, for example, clicks on button. Let's think about real life example. Add to cart, right? We have list of products, and we want to add products to cart. And we have user who decided to click every of the products really fast. But now we have a lot of actions dispatched to our reducer, and we want to handle them, every of this action, in given order that was used by our user to have the order in cart. This is a pretty hard to handle it, because when we use just promise, every of our requests can take longer or faster or longer, so we have no control which one will come faster. So we can just use Sagas for that and create a channel which takes every of our action dispatched and queue it. Of course, wait for the API to be made, and then go to the next from our queue. This is cool. And the bounce or throttle, our event. So the bounce or throttle, do you know the difference between the bouncing and throttling events? Yes, mostly yes. This is like a common patterns of JavaScript develop applications. It's usually we do it with our JavaScript code connected to input directly, right? But this is again keeping the logic in component, which should be really simple and logic free. And when we have Saga, we can implement the bounce really fast and keep the logic inside the Saga, and still keep reducer informed about any input change which was done. Because mostly when we implement our debounce, for example, in React and in Redux, we try to to do some delaying of the reaction for the action, for dispatching the action, which means that state is kept in the components itself, not in reducer, because reducer doesn't know about the change. It will know when we stop typing, right? So Saga keeps it really clean and still delay the future API call. So what we have inside our Sagas? We have effects. This is what we actually use in Sagas for, this is our building material. We have put, which is a putting action to dispatcher. So we just put our action and then inform reducer that something was changed and something was succeeded or errored. Or of course take. This is very important because take in Saga actually listen to action type, which is very important because this is how it works. Call and all and raise. So call means that our Saga want to call some action, for example, fetching the data, or maybe call another generator. All and raise are actually promise features, which, as you probably know, means that you can, in concurrency, call many generators or many async operation, or raise, which means that you are calling many operations, but the first wins. First which will be back, of course. So select. Select is really awesome also. This is an effect which just selects some part of the state from the reducer. Sometimes it's really important to use that. For example, if we need user ID or some other ID which we need to do another request, this is a select operation, which can also fail and inform our reducer that, oh, well, we haven't found this ID, and the whole Saga errored. The fork means that our generator will be called in the background. So, which is a really powerful, because fork always returns this generator instance, and we can cancel it. Oh, this is a huge thing. We can cancel our operation, async operation. Okay, so real-life examples. Oh no, why from the end? So we can retry, really simple retry our API calls. This is huge. This is really huge because actually it's possible, right? With the low internet connection, or even our server went down for a while. Usually it means for an application that it also will bring our 500 error, maybe show some error, but how we handle the retry to communicate with API again. So with Saga, it's pretty simple. We can just implement our Saga to, for example, wait a while, delay 1 second, and try again. And even we can just set Saga, look, try 5 times. If it won't work, then okay. Combine multiple async operations. This is also a cool feature because always when we are implementing dashboards, for example, we usually build dashboard from many parts of data. Usually, of course, when we are in a good communication with API developers, we get one bunch of data in one call, which is cool. But sometimes we just have to do multiple requests and get our data, and then show the succeeded screen. Of course, we can do it with a concurrency, so all of our parts of our data will just show at the same time. But if we want, we can also schedule our async operation, which should be loaded first, which should appear first, which should be loaded after all. And this is pretty cool, right? You are not agree with me. Never, like I'm asking you, and what's happened? So, and yeah, cancel previous operation. So imagine that we are going through our application many times, we're just switching pages, and every time we enter a page, some kind of API request is going on, right? So we just go to the, I don't know, gallery. And we just switch the photos categories. And every time we just switch the category, the request is going. So, but what's happened when the user just simply goes through the categories really fast? Every request is going on, right? Because we cannot cancel it. We cannot just say, okay, stop it. We can, of course, say, don't listen to it. That's right. But the request went. So we can actually, with Saga, cancel the previous operation. So when some user clicks really fast through the categories, we just simply say to our Saga, look, this request was done again. Just cancel the previous one. Don't do it. And use the newest. So now I will try to sit to my really dinosaur IDA web storm and show you something. Hopefully, I mean, I have code written, I have prepared to this because I know that it can be nasty to just show you something writing at the same time when presenting. So let's start with our React app component, which is, as you can see, a really simple component, used styled components, really cool. I really advise you to learn it. And we have just 2 rows, 2 pages, which are nodes, and add node. So just to go through a really simple, really fast, go through our application, we have, this is really small for you for sure, but for the need to implement Sagas, I had to prepare reducers and containers and components. And when we go to the container, which is a container which keeps nodes, I actually dispatch method get nodes, as you can see. So our request nodes, when the component did mount, is dispatched. And when I go to my Saga, which is listen to the given action, it's a really small Saga, right? Can you agree with me? For once, it's a small one. And as you can see, it's pretty simple. What it does, it just takes the latest, which is a really cool helper of Sagas. It does the work for us. It means take the latest call, take the latest dispatch action, get nodes, and just refresh our data. And everything which is going on in this part of code is going under the hood. So a user is not informed about that. He will be informed about loading state and, of course, ready state. So what is going on? I did, for the case of our presentation, because this should be done better, for example, in services utils, not here. But of course, I do the call when I do the fetch. And for the case of this presentation, I prepared a really simple Express.js server, which is here, really, really simple one, which reacts to the get nodes and returns the JSON with some kind of nodes, right? And then goes back to our Saga. I do the call, the fetching data. I do the delay to show you that it takes some time. It takes a while. And then when it's done, when the delay is done, it goes to another line of code, which is a put to dispatcher action get nodes success with response. So this is it. This is the whole Saga. Now the panda. How it works in our application. This is pretty small, but I'm using a really cool tool for Redux. Are you familiar with this tool? This is really awesome to just observe what actions has been dispatched to the Redux, to the state. And in our application, when we did get nodes on the component did mount, I do the refresh. We have loading. We have get nodes, which is get action dispatched to the state and taken by Saga, and we have just done the job, and our action has been dispatched with the new nodes. So this is the first example. Let's go to the more complicated one. Okay. So as I've prepared some code just to be sure that I will show you something today. So another and more complicated problem is the bouncing our call. So with the bouncing, it's pretty. I will show you at the beginning how it works. So when I'm typing, it will just get data. When I'm stopped, it will save. Right? This is how works the bouncing. Of course, I could done it better, but it works. And how it works under the hood? It's really cool because it's again Saga, and our component does nothing more than just dispatching action. So I will show you the component to just make sure. So our component has some input, which on change dispatch our action. Right? So logic is out there. There is no logic inside this component besides the map state to props and map dispatcher to props, which is cool. But the whole logic behind this async operation is in here, and it's pretty small, right? It works simply as that. It just with a while of true, which is really important to make the generator works and observe the action all the time. You just take the add node, which is our, of course, there is some payload, which is our text from input. If there is a task, this is really similar to the pattern used in many languages with which is a singleton, right? So we have an instance of a task, and if there is an instance of task, we do cancel it, and then just create another one and forget. Inside, I just do delay. I said to myself, okay, someone is typing. I will give him 1 second to stop, and then just save our node. And then, of course, because this is how sagas communicate, they communicate through actions only. I put the at node success, and this is all. This is done. The bounce is done, and the logic is inside sagas. So this is cool. And of course, we share the states, so our nodes are here at the same time. Okay, so let's go back. I should prepare another really cool part of code, but I decided to just take it from Redux Saga documentation, which is really also nice because you can just learn Redux Saga really fast and simple as that, because there are ready-to-use patterns and implementations. For example, retrying our API call, API call. So what's going on here? We have taking the action, which is update start. Then we're just trying to call our update API Saga. And the update API Saga generator does the work. It tries 5 times, tries 5 times to call the API request. If it catches an error, it tries again to call the delay, and if an error comes, it just goes back to the for loop and starts the whole party again. So this is it. Thank you. Do you have some questions to me, to the how Redux Saga works, how to start, what's next, or a feedback? I will be really pleasant to hear it.
So there's no
Okay, so put effect takes only object of an action. So only object created by action creator. So put means that you put something to dispatcher. When call means that you are calling some other part of code, some function, some other generator. So this is the main difference.
Thank you.
Yes, of course, this is the future of sagas. They want to implement async await. They just have wait to make it more stable. And probably this is the future they want to use. Yes, it's a pretty fresh approach to the generators. Yes, exactly, because this is what Sagas does. It just implements, connects the promises with generators under the hood, as async await does. But
what is the output code when it's transpiled?
Oh, that's a good question. I have no idea. Yeah, of course. Generators returns promise every time.
But promises also transpiled?
No, it's a native promise.
But, for example, it's better to use for real world because current implementation, for example, in Chrome, it's not a native implementation of promises, it's JavaScript.
Oh, yeah, of course. Yeah, it's there is a Babel plugin to transpile the whole Redux saga into our current supported JavaScript version.